Hey everyone, welcome back for another deep dive. And today, well, we're diving into something a little different. We're taking a deep dive into the world of argon.
Argon.
Yeah, that element is hanging out there on the periodic table, but um, as we'll find out today, there's way more to argon than meets the eye.
It's true. Argon doesn't always get a lot of attention. It's colorless, odorless, and it's known as a noble gas, meaning it's not very reactive.
Yeah, it doesn't really like to play with others, does it?
Not so much, but that's actually what makes it so interesting. It's the quiet one in the room that's silently playing a critical role in some really unexpected places.
Okay, now you've got me intrigued. But before we get to all the exciting stuff, let's back up a bit. We're talking about a gas that makes up almost 1% of the atmosphere, right?
Yeah.
That's right, almost 1%. You'd think with that much of it floating around, it would have been discovered a lot sooner.
Exactly. How on earth did scientists miss that for so long? It's not like it was hiding in some, I don't know, some remote cave somewhere.
It was hiding in plain sight. And ironically, it's that lack of reactivity, its laziness, so to speak, that made it so elusive for so long.
So the very thing that makes argon so unique is also what kept it hidden in the shadows for, well, for quite a while. I guess if an element doesn't really interact with anything, it's not going to leave behind a lot of clues for scientists to find.
Exactly. It's like trying to track down a suspect who never leaves their house and never interacts with anyone. Pretty tough to do.
A true master of disguise. It blends right in. So how did we finally uncover argon's secrets?
Well, it starts with a scientist named Henry Cavendish back in 1785.
1785. That's, what, almost a century before argon was officially discovered?
Right. And get this, Cavendish actually isolated a sample of argon without even realizing it. He was studying air and noticed this tiny portion that just wouldn't react with anything.
He must have been pulling his hair out.
He knew something was off, but he couldn't quite figure out what it was. Talk about being on the verge of a major breakthrough.
Wow, what a near miss. So how did we finally get from this mysterious, non-reactive gas to actually putting a name to it, to saying, hey, that's argon?
It took two incredibly meticulous scientists, Lord Rayleigh and Sir William Ramsey, to finally crack the case. They were analyzing nitrogen. And notice something peculiar. The density of nitrogen they extracted from the atmosphere was slightly different from the nitrogen produced through chemical reactions.
Hold on, how slight are we talking here?
We're talking a tiny discrepancy, something like 0.5% difference.
0.5%, that's an incredibly small detail to pick up on.
It is. But it was enough for them. That tiny difference told them that something else had to be lurking in the air, something previously undetected.
Like finding a needle in a haystack, except in this case, the needle is an invisible, unreactive gas.
Exactly.
So we've got argon, this element that basically flies under the radar because it's so unreactive. You'd think that'd make it, well, kind of useless, right?
You'd think so, but that's where things get really interesting. You see, argon's laziness, that's actually its superpower.
Okay, now you're really piquing my curiosity. How can being lazy be a superpower?
Because it's so reluctant to react with other elements, it's incredibly valuable for protecting things that are prone to, degrading over time.
Now that you mention it, I do remember reading something about argon being used to preserve historical documents, like really important ones. Is that one of those unexpected uses you're talking about?
Exactly. Think of the Declaration of Independence, that iconic document. It's actually housed in a special case filled with argon gas. And because argon doesn't react with oxygen or anything else, it acts like an invisible shield, preventing the paper and the ink from deteriorating.
Wow, so argon is like a silent guardian protecting some of our most precious artifacts, but I'm guessing its talents don't stop there, do they?
Not even close. Let's talk about food, for example.
Hold on. Food? What does argon have to do with food?
You might be surprised to hear that argon is actually a common additive in the food industry.
Really? You're blowing my mind here. So we're talking like putting a gas in our food.
Well, not exactly in the food, but because of its innate nature, it's often used to displace oxygen in packaging to keep food fresh and prevent spoilage.
Okay, so it's more about using argon's stay out of it attitude to keep things from going bad, rather than actually adding it to the food itself. I feel like argon is full of surprises. What about, say, the poultry industry? I know argon's used there too, right?
You're right, argon is used in poultry processing, and it's all because it's denser than air.
Okay, how so?
Basically, they can use argon to displace oxygen, leading to asphyxiation in poultry, which is actually considered a more humane alternative to traditional stunning methods.
See, this is what I mean. Argon's resume is all over the map. preserving priceless documents, keeping our snacks fresh, and even playing a role in ethical food processing. Oh, wait, there's more, isn't there? What about argon's role in, say, space exploration?
You're on a roll. Argon's role in space exploration is all thanks to its isotopes.
Isotopes. Refresh my memory. What are those again?
Sure. Isotopes are basically different versions of the same element. Think of them like siblings, right? They all have the same basic characteristics, but with slight variations. And one of argon's isotopes, argon-39, is incredibly valuable for dating ancient materials.
Ancient materials. So we're talking dinosaur bones ancient.
Think way older than dinosaurs.
Yeah.
We're talking about analyzing ice cores that are millions of years old, or even studying ancient groundwater to unlock clues about Earth's history.
Wow. So we're going way back in time with argon. So it's not just preserving history, but it's actually helping us unravel it. And you mentioned something about other planets, too. How does argon factor into that?
You see, different isotopes of argon are found in things like meteorites. And by studying those isotopes, we can learn about the composition of those objects and even get clues about the formation of our solar system.
So argon is like a cosmic time traveler carrying secrets of the universe within its atoms. Who knew this seemingly simple element was involved in so much?
It's true. And there's still one more twist to this story, something that really sets argon apart on the periodic table.
Okay, now I'm really on the edge of my seat. What's argon's big secret?
It all comes down to how argon is formed here on Earth versus how it's created in stars. And let me tell you, the process is completely different.
Different how? You've got to give me more. Okay. You've been teasing this whole argon anomaly thing. What's the big reveal?
Well, we've talked about how argon-40 is the most abundant isotope here on Earth, right?
Right, argon-40. Got it.
And it turns out the way argon-40 forms, well, it's kind of a rebel on the periodic table.
A rebel? How so? I mean, it's just an element, isn't it?
You see, most of Earth's argon-40, it actually comes from the decay of another element, potassium-40.
Okay, potassium-40, I'm following.
Now, stick with me here. On the periodic table, elements usually get heavier as you go down each row.
Yeah, that's the whole deal. Heavier as you go down, lighter as you go up.
Exactly. But argon-40,
Yeah.
it kind of missed the memo on that one. It breaks the mold.
Wait, you're saying argon-40 is actually heavier than potassium-40, even though it's higher up on the periodic table?
You got it. It goes against the grain. Argon-40, heavier than the element it came from, even though it's supposed to be lighter. It's like it just decided to do its own thing.
So argon isn't just, like, silently observing. It's a straight-up rule breaker. I mean, we're talking about the laws of the periodic table here. But you mentioned that argon forms differently in stars, too, right?
Exactly. And this is where it gets really wild. Out in space, stars create argon through a process called stellar nucleosynthesis.
Stellar nucleosynthesis. Catchy name.
And the main isotope stars produce is argon-36, not argon-40 like we find here.
So it's like argon has a split personality depending on where it's coming from. Earthly argon, it's all about that rule-breaking argon-40, while stellar argon is sticking with the program, argon-36. Amazing. But what does it all mean?
It tells us that the argon we find here on Earth, it didn't just magically appear. It had to come from somewhere else, a place with a history of potassium decay.
Hold on, are you suggesting that the argon we're breathing right now, some of it might have actually originated in the heart of a star billions of years ago?
It's incredible, isn't it? Think about it. The air we breathe, the very ground we walk on, it's all connected to these cosmic events from eons ago. It really puts things into perspective, doesn't it?
It really does. Who knew argon had such an epic backstory? I mean, it's not just an element, it's a witness to the universe's history.
And the best part is, we're still learning. What we see as inert and unreactive today, who knows? It might hold the key to some incredible breakthroughs in the future. New technologies, scientific discoveries, the possibilities are endless.
That's the beauty of science, right? Always more to learn, always something new to uncover. Just goes to show you never know what you'll find when you take a deep dive.
Couldn't agree more.
Well, that's about all the time we have for today. But wow, what a journey. From the depths of the periodic table to the vast expanse of space, argon has definitely proven that it's anything but boring.
It certainly has.
So until next time, keep exploring, keep asking questions, and never stop diving deep into the wonders of the world around us.